So in the end, we ran all over the place. In the end, you should have done 7 vectors. And notice, were the directions like intelligent and coherent? Or were they like which one? Yeah, the guy's like having you go north and south. He's nuts, right? And we only did like, 8 paces, 25 degrees, 8 meters, 12 paces, 210. But what if instead of 8 meters, it was 8 kilometers, right? Or 80 miles. Would that be like really painful? It would, right? So here's the goal. The goal is you're going to be a smart pirate. You're going to beat Captain Jack Sparrow at his own game. A little precision pirating, okay? So here's your goal. Your goal is to draw a treasure map and show me exactly where the treasure should have been, and then just go straight there. And in fact, that's what I did. So while you guys were running around like crazy people, I put in what the resultant should have been on my compass, and then I secretly, when no one was watching, went to where it should have been. Okay? That's the goal. So the first thing is, let's review the compass directions. North is which way? You guys remember? On a map. North is straight up usually, and that's 0 degrees. Okay? To the right we call what? East. Here we go. Don't get confused. Down we call south. And to the left, we call west. Some people got their compass flipped around. That's why they're going the wrong way. So try not to do that in real life, okay? 90 degrees is east. South is 180. West is 270. That's very important. Your math class is the wrong way, okay? Compass directions go clockwise. Math class goes counterclockwise. Compass directions due north is straight up. 0 degrees. Math, it's to the right, okay? Anyhow. Next, you need a scale. I just picked something convenient so it fits on the paper. I said that 1 centimeter is 2 meters or 2 giant paces, whatever, right? And then everyone's going to start at his tombstone right here, okay? So let me just show you how to get started. So I'm going to do first vector. You just do whichever one you had first. I had 8 meters, 25 degrees. So the first thing to think about, common sense, which way is 25 degrees? The general direction. It is what? Which way is 25 degrees? It is in the northeasterly direction, okay? 25 degrees, 8 meters is what I'm going to draw here, okay? So a little hint to make this easier for you. I'm going to zoom in here. Wherever you're going to draw a set of directions, okay, a displacement vector, let's use a fancy word, okay? Draw in a set of compass coordinates to help you line up your protractor, okay? So I'm going to draw in an X and a Y, a north and a south, an east and a west, okay? That'll help me line it up. And now what I want to do is I want to measure 25 degrees. And everyone's like, how do I measure 25 degrees? I just randomly pick 25 and draw it? Well, no, you have to orient yourself to the compass. So again, if 0 degrees is due north, I want to do 25 degrees east of north, okay? Oh, I zoomed in too much. Hold on a second. So I want to do 25 degrees east of north. So what I'm going to do is I'm going to take my protractor. There's this little hole here. That's called the vertex, okay? You want to line that up right with where you want to draw your vector. Okay, and then I'm going to measure out 25 degrees. So on my protractor, it's somewhere like way out here because my protractor is huge. And then what you want to do is draw to scale. And if I'm trying to do 8 paces or 8 meters, okay, then if 1 centimeter is 2 meters, it's a 2-to-1 scale. I want to draw this what? How big? I want to draw a line 4 centimeters to scale. That's all. I'm just trying to draw a scale map, okay? So all I got to do now is take my ruler, line it up with 25 degrees, and draw a line exactly 4 centimeters long, okay? So it's going to look something like that, okay? There we go. This is my 25 degrees in here, okay? And label this. This is 8 meters, 25 degrees. All vectors have both a what? A size and a direction, okay? Put an arrowhead on it because you don't want to have a headless vector. You want to know which way you're heading, okay? How would I draw my next vector? How would I get started? Can you picture it? Okay, again, a little trick is what you want to do is draw a set of compass coordinates, an origin to help you mark it off, okay? So with my ruler here, I'm going to go ahead and mark off right here my next set of compass coordinates so I can line this up properly. So maybe something like that, okay? And let's just say randomly, someone give me another direction. It really doesn't matter the order. Call off one. 12 paces, 210. Okay, so we're going to do 12 paces, 12 meters, 210 degrees. So the first thing to picture is what general direction is 210 degrees? 210 degrees is which way on the compass here? 210 is which way? There we go. 210 is to the south what? 210, careful. Southwest, okay? It's 30 degrees south of west. 180 plus 30 is 210. Did I do my math right? I think so, okay? So all you got to do is take your compass, line it up, your protractor rather, with the north, south, west, east. Make sure you have it all lined up there. And then you want to go which way, east or west, if it's 210? You want to go to the west. So anyway, if I measure this carefully, I'm just going to go 30 degrees west of south. So if I line this up here, it'll be out here. I take my ruler. 12 meters is 6 centimeters to scale. There we go. So it'll look something like that there, okay? So notice we almost double backed on ourselves. This guy is like totally wasted. He's having you go in like random directions. Label it out, okay? So this is my first vector, number 1. This is my second vector, number 2. When you're all done, okay, here's how you wrap it up. In the end, you should have 7 vectors drawn out. And when all goes well, your goal is to find the result, okay? Label that. That's called the resultant. It's an R with a half arrow on top. That means it's a vector. And all vectors have a size and a what? Size and direction, okay? So what you want to do is draw in your result. It's always from where you start to where you end up. X marks the spot. Make it dotted, because you didn't really do that. You ran around in 7 different directions. But the resultant is the result of adding up 7 displacement vectors, right? And then how do you get the size and direction? Easy. You measure it to scale. I got it to be 10.6 centimeters. If 1 centimeter is 2 meters, it's 21.2 meters to scale. And then how do I get direction? I do what? I measure it, right? And I got it to be 169 degrees. So are we going to get exactly the same thing? Are we going to be a little bit different? What do you think? A little bit different because there's a little bit of human error. The big error is measuring the angle, actually, okay? But that's okay. Ballpark, it should be about right. In real life, what's funny is even with all this technology and GPS and all that, airline pilots and captains of boats, they still draw it all out on a piece of paper. Because in the end, you don't want to rely on a machine, because a machine is just a dumb machine. If you program it wrong or it crashes, you're going to crash, right? So you still got to use common sense there. So a pilot can draw out to scale the velocity vector of the plane, size and direction. If there's wind blowing, they can draw that in, and then they know the true heading and course of an airplane. And then they can make corrections on the fly so you don't end up in the wrong city, okay? So for tonight, that's your goal, precision pirating. Beat Captain Jack Sparrow at his own game. Tell me exactly where the treasure